So what do you mean by heterosis? Heterosis refers to the superiority of F1 over the parents, maybe for any yield, adaptation, or any character. Okay, that is superiority. This F1. Okay, this we have parents. The superiority of this F1 over the parents. Okay, is called heterosis. It can be in any terms. It can be like yield. It can be some adaptation traits or disease resistance. Anything it can be. Okay. So other things may not be much required, okay, for the CSC. So heterosis is having always a positive advantage or positive association with heterozygosity. Heterozygosity means capital A, small a. Okay, different alleles are mixing. So in UPSC, what we usually find is that questions like what are the types, okay, then what are the physiological basis, molecular basis of heterosis. These are the major things we study, okay, or they are asked in it in civil services. So first we will see the genetic basis. See, what is genetic basis? That is like dominance hypothesis. This was given by Davenport, Bruce, Cable, Pelham. Okay, that you may not need to know. Heterosis is the result of superiority of dominant alleles with respect to recessive deleterious alleles. What happens, here we consider capital A is dominant over small a. This is what is the consideration in case of dominance. This is the most widely accepted, okay, most accepted principle, and this is what is the basis for any genetic principles when we study under. We use these of dominance. What happens in case of housekeeping genes or the normal genes which are involved in the development and all, we it shows dominance. Okay. Next is the over dominance hypothesis. So what happens in case of over dominance hypothesis is that there is superiority of the heterozygote over its both of homozygotes. What does it mean? See, for example, we have capital A, capital A. This is parent one. Okay. This is parent two. Small a, small a. This is the genotypic configuration of the allelic, okay, in a particular gene. So you are getting capital A, small. What happens, in case of over dominance, we say that capital A, small a is superior over both. It may be this one, it may be this one. Sorry, not this one. Okay. So the superiority of heterozygote over the parent or the even the homozygote, like even capital is there, still capital A small a is the boss. Okay, capital A small a is the boss of the one which is going to determine the heterosis. Okay, so this is also called superdominance or cumulative action of divergent alleles. Okay, when we have divergent alleles, okay, divergence means different alleles, then it leads to heterosis. But what happens in dominance? You saw that capital A, small a, yeah, capital A will be dominant over small a, small a. Means once capital A comes, then it is dominant only. No question. Like it may be capital A or capital A, small a. But here you should understand the concept. Capital A, small a per se heterozygosity is the one which is making the way. Yeah, mostly it is in terms of regulating genes we find, and it is like less accepted methodology. Okay. Next is the epistasis. What is epistasis? There will be interaction between different loci. Okay, there may be some sort of interaction. Okay, this is also called non-allelic interaction. So we have three different types. One is additive into dominance, and dominance into dominance. So what happens, only majorly in case of dominance to dominance. Okay, there that involves dominant effect. Okay, and this may contribute to heterosis. Mostly this is the thing. Okay, because dominance into dominance. Because in heterosis we have three different signs: additive into dominance, and dominance into dominance. And in case of dominance to dominance, we usually believe that there is heterosis. Okay, and this is observed in case of cotton and maize. Next, very important concept is fixation of heterosis. Okay, these are the things you should know. First is asexual reproduction, because they are fixed. Your one plant is there, then you are going to use this part and going for planting. So the heterosis is conserved. Okay, that is one way. Second is by apomixis. I think you know what is apomixis. Production of seed without fertilization. Okay, so some plant will be there. Okay, some female plant will be there. There will not be no fertilization. Still, the seeds will be formed. So the heterosis, like for example, if the plant is capital small, still it will be conserved because we are not crossing, right? Okay. Next is balanced lethal system. This is a bit complicated, like involving complex translocation. We can conserve heterosis. Okay. Fourth is polyploidy. So in case of polyploidy also, there is chromosome doubling, okay, or chromosome doubling or polyploidy, like in case of wheat into rye. Okay, by this also we can fix heterosis. Next is heterosis depends on what are the measures, like mode of pollination. So let me tell you, there was a question we asked about why in cross-pollinated crops heterosis is more compared to self-pollinated crops. So the mode of reproduction is important. Okay, how it is important? What happens in case of self-pollinated crop is that because of evolutionary history, uh, there is lot of homozygosity already present. Okay, and all the deleterious alleles, like deleterious means capital S, small a alleles, recessive alleles, are already eliminated. Okay, or they are not exposed. Okay, in case of self-pollinated crops, and by the evolution, okay, they have something called homozygous balance that that protects them from inbreeding. Okay, but if you see in case of what happens in case of cross-pollinated crops, so the heterozygous combination will be there in most genes, capital A, small a, like that. So once you self it, okay, then it will lead to capital A, capital F, capital A, small a, and small a, small a. So the heterozygous recessive allele is exposed. Okay, so that is the reason why the inbreeding depression is more. This is a very important concept. I don't think in many places you may not find it clearly to understand. Okay. Next is genetic diversity of the parents. They need to be diverse as possible. Genetic base of the parent. Okay. It should have a broad genetic base that is having like GC effect and all. Okay. Then the adaptability of the parents. It also depends on how adaptable they are. If they are more adaptable, then we can expect more. Okay. Then estimation of heterosis. We have three: average, heterobitiosis, and economic. So I know that you know that in average heterosis, like the F1 will be better than the A and B with respect to average. Like if this is 5, this is 5, 10. Okay. Average is 5. Okay. If this is 7, if F1 is giving 7 kgs, then this is okay. Average heterosis means when you average it, you're getting 5 and 7 is better than 5. Okay. That's what mean value of the parent. Next is superior F1 over better parent. Better parent means what? Heterobitiosis. Like one parent is giving 7 kgs yield. Okay, another is giving 5 kg. So the plant should give 8. Okay, if it gives 8, then what do you say? F1 is superior over better parent. This is better parent. Okay. Next is economic heterosis. Economic heterosis means the F1 or the hybrid is better than the commercial variety. Okay, there will be some check like 10 k, some plant will be giving 10, 15 kgs different. So if your F1 is better than these commercial varieties which are cultivated, okay, then it is called economic heterosis. Okay, what will happen in case of heterosis? There will be increase in yield, higher yield of fruits, okay, hybrids, increase in crop size, tomato hybrids are there, greater resistant to pest and disease, okay, hybrids are more adaptable, will be faster growth, okay, these are the advantages. Next, most